Science teacher training video number 3. Why do people in the deserts wear black clothes where science would say they should wear white ones? Investigation, get the students to find out, get them to think about it, look it up, find it out, discuss the next lesson. When you get to the next lesson, pose the question again, see who puts their hands up, pick the people who put their hands up the least first to give you their ideas, what they found out. Only allow them to do 1 point each and get a mark. Great, you've got your mark, let somebody else get their mark. And then pick the next person, the next person, the next person, so that after a while there'll only be the kids that work at the hardest with their hands up, still with something more to add that nobody's said yet. Give a capital A for a good answer, a small a for an answer that helps, and put them on board, get everyone to write them down. Great way to start a lesson. Good homework with consequences, with marks for your reports, and you don't have to spend a long time marking it, ticking books and stuff. It's a good one. Goes in homework diaries. Next one. Why is it coldest in January when the Earth is closest to the sun? Things that don't sound like they make sense, you have to investigate them further to find out what's going on. Why are bananas berries, but strawberries are not? Why are they classified this way by biologists with reasons? What's going on there? Oh, and tomatoes as well. We might eat them as salad and vegetables, but really they're fruit. So what is a fruit? What do biologists mean by this word? Why is it important? Lots of things to answer. One thing each, put it on the board. Spread the marks around so that the most people, I'm continuously saying to my students, I want everybody to get good marks this week. But, sometimes nobody else has got the answer, and I'm having to drag the answer out of other people, and Simon's always getting the right answers. What things are attracted and repelled by the surface of water? It's a good experiment, something for them to video, but you have to get them to video the experiment and not themselves. And then maybe you get to put them on the YouTube channel. Excellent. Another experiment for them to video, make notes on, do, investigate, is a dripping tap. How to make a dripping tap louder, how to make a dripping tap quieter. To do the experiments, write down the apparatus, the method, how they decided which was louder and quieter. They're going to use their ears. And what to do with the water from a dripping tap, how you can use the water from a dripping tap usefully until you get the washer so that you can find out on YouTube how to change the washer in a tap when you're the person that pays the rent or owns the house. Good. Why are whales and elephants and humans classified as mammals? Surely they're very different. How do biologists do their classification? Good. Oh, one for maths, quick in there. Measure the distance between the top of the hinge and the top of the door, the bottom of the bottom hinge and the bottom of the door, and all the parts in between. Write those numbers down, the spaces between the hinges. Are they symmetrical? Why not? Why do we put them unsymmetrical into a door? Because there's an optical illusion, because people are mostly looking down, and it looks very weird if you put the hinges on symmetrically on a door. It just looks wrong from the point of view of where human eyes are. Home experiments, other ideas. Getting a lamp to shine light through water, and then add milk, drop by drop by drop, and make observations. When is the light reflected? When is the light transmitted? But don't say those words to them. Get them to say the words to you, and then underline them, saying that's a brilliant word, well done, good mark, who can spell it? Capital S for spelling it entirely correctly, small s if you're helping out. Investigation, invisible ink. When was it used in history? Who needs to use it? And how was it done? Many different ways of doing it. And the colour of oil when dropped onto water. How to get things that are common knowledge and often wrong. For instance, many scientists will say, what was the greatest invention for humans? And they'll say, oh, it was the washing machine, because it saved so much time so that people could go and do other things, work and such like. And then there was a study in the 1920s about how much time people spend doing things. And so I would put TV dinners. And my source of information there is the 50 things that made a difference in economics podcast. Tim Harfield? Anyway, so he said, no, people in the past didn't spend a long time washing because they'd wear the same shirt for 10 days and then spend a lot of time on washing it just the once. And that's why they had replaceable cuffs and replaceable collars. So, yeah, in the past, people did spend a long time preparing food because they weren't prepared to starve, but they didn't spend a long time every day washing because they weren't worried about smelly enough. Next one. Don't sweat the small stuff. So getting the students to understand that there are times when there are poisons that are not a problem to you. For instance, there's cadmium in chocolate. Yes, there is. But is there enough that if you eat a human sort of amount, I'm not talking eat 10 kilograms every day, but eat a reasonable amount of chocolate every day, what's your chance of dying of cadmium poisoning? Much more important is seatbelts. Worry about seatbelts. Don't worry about the cadmium in your chocolate. There are lots of things in your chocolate and the rest of your food. And some of them are bad for you. And some of them are cumulative, like the heavy metals, mercury, cadmium, the rest. So you should be aware. It's the reason why I suggest my students find out which countries have got the most cadmium in their soil because of making technological things like iPhones. You make iPhones, you get heavy metal pollution. If you're in a poor country, there's no regulation, so just chuck it out. It ends up in the river, in the soil, in the food. And so therefore, you don't want to be eating food from certain countries. China and India. And DDT, also used in these countries. I check my food out, find out which country it's come from, find out whether or not that country is a good idea to eat food from. Other things, don't sweat the small stuff. There was a case when it was found out that you double your chance of a disease by being on the pill for ladies. And so lots of ladies panicked and stopped being on the pill. Whereas the death went from 1 in 10,000 to 2 in 10,000. As a consequence of all this news, lots of ladies went off the pill, lots of ladies got pregnancies which they didn't want. So lots of ladies then had abortions, lots more ladies died due to those abortions and the other ladies that went through births that they then didn't want. If you sweat the small stuff, sometimes you'll go away from something that keeps you safe and towards something that means more people die. Know about the small stuff. Know when it is small stuff. Know when to panic when not to panic. Someone runs around the room shouting, "Gas, gas, gas." Don't start jumping out the third-story window yet. Ask them which gas. Because if it's oxygen, ooh. If it's fluorine, yeah, okay. Another investigation. Why do electricians touch bare wires with the back of their hand rather than with the front of their hand when there's anything that might have electricity through it? Investigation. Get them to find out. These investigations might take 1 minute, 5 minutes. Some students will get down the rabbit hole and get a whole bunch of science and learn new words and learn new stuff and get excited about science. The reason why is because if you get an electric shock in your hand and electricity's in front of your hand, the finger side, your muscles automatically flinch to hold on to that thing. Bad. Whereas if you touch something with the back of your hand will flinch away. To keep students interested in my classes, I talk fast sometimes and then slow other times, and I try to not have words that are not necessary, like, is. I allow silences in the words that I have. Politicians do this. Speech writers suggest this is a good idea. So the people listen to the words. Fast, slow, high, low. And also unusual things. Like when I want a spelling, I'll just say S. If a student says a word and I want it spelt so I can put it on the board, I'll say S. And they'll listen for that to get the marks for their reports. I actually say how many S's they got, how many helpfuls, how many answers, and yes, how many times they stopped the class. So, bad behaviour too, gets a mark. Physics investigation, cup full of water. How to make it spill and how to stop it spilling. Walking backwards works really well. It's a problem. So I say the problem as a real life problem. I want to walk across the staff room. I always find that if I do it in certain ways, I get to spill my coffee. That's difficult and embarrassing. So I wanted them to find out how they should stop this happening to them in the future. Yeah, walking backwards is a bit complicated if you're doing it in the staff room, but otherwise you do the dune thing. Walk without rhythm, so that you don't get a loop, a reinforcing, positive loop thingy. Feedback loop, I remembered. Another one to do is to get a student to fill a cup full of water, and then other students come up and put one drop in. Each time they're saying, surface tension is my force. Getting that word retreated over and over and over again, and then them seeing how much more water can go into the cup because of surface tension, holding water in. That's fun. When doing posters for walls, and I'm doing the drugs topic, I like the students to pick one drug each. So put the hand up, they get their drug. Other people help with spelling it, put it on the board. Everybody writes it down so that nobody does the same one as somebody else, hopefully. Or you get people in pairs, depending on how big your class is. There's definitely 15 or so. And the thing I want them to have in there is about approximately 30 words, not less than 10, not more than 40. And, oh, hold on. And I want them to emphasize the dangers of that particular drug that they've got, particularly using famous people. Now, it won't be famous people that are in their 20s because it takes time for drugs to take a hold. So it's got to be famous people that their mums and dads, their grandparents have heard of. So find out what happens to people when they take too much of this drug and it has effects on their body. For instance, the one that I always say is, I know 2 friends that have used lots and lots of heroin and other opiates would do the same thing, fentanyl probably, that's in the US, really big at the moment. It makes you wrinkly. And that's what happened to the 2 friends of mine that took too much of those poppy derivatives. Yes, from flowers. So I will give them marks, particularly if they're using their own ideas, and if they're saying things that I don't know, and if they're emphasizing what the drug does to the person, the disadvantages. Not so much the inside disadvantages, more the things that happen to your face or so. So that it will discourage younger people from taking these things. And of course, as they're researching these things and reading them, because I put them on the walls so that once they're queuing up to come into my room, they can see all the other posters. And so this is the way I'm going to mark them. I mark them clearly in a way that is transparent. So I say also, I want scientific words to be involved, and I want it to be linked to GCSE science curriculum. So if you've got all of those things, you get the most marks. I give 2 marks, one for how sciencey it is, and the second mark is for neatness and effort. So yes, if it's wonderfully drawn but doesn't have any science in it, you'll still get one of the 2 marks would be good. And so yes, I go 1 to 9, the same as the GCSE, for how much science there is in it. So I predicted grade for the GCSE, say, based on this one piece of work. And also I give an effort and neatness grade, where C is about what I could do pretty easy in 20 minutes, and then a B would be extra neat, and A would be extra neat and extra effort. Not lots of words, but interesting to look at. Draws the eye. Other things, as I'm doing reports back, when I'll say something about science and they find out about it, an easy definition will be, yeah, okay, that's one marky thing. The history behind something is always interesting, particularly if they find things that I didn't know. Any equations that are involved, particularly if they're GCSE equations, and put them on the board and go, hey, this is an equation that has this effect on this part of science, whether I'm doing cars crashing or something else that has momentum equations. Pop culture references. For instance, James Brown, when teaching gravity, because James Brown does his song Gravity, Big G. And so that's for my A-level students. And what people misunderstood and has then been corrected. What things people got wrong about this science and now get right. I also tried to put real apparatus rather than scientific apparatus, rather than a whole bunch of rods and bits of candle wax and other things that students don't really have in their everyday life. To do the conductivity experiment in physics, I like to use different metal spoons. Thin ones, fat ones, short ones, long ones. Put a blob of butter on them and a pea. And when the heat gets there, the butter will melt and the pea will fall off. Hopefully, if it goes right, that's that theory. Then, of course, then I have to discuss why it's not fair to have a short spoon against a long spoon, but a fat against a thin one, that is okay. Well, short against long is okay if the pea is at the same distance away from the heat source. And I have to discuss how much butter they should use, the same amount each time. And, you know, the pea should be the same size each time, but then peas mostly are. Cool. if, for instance, I'm going to do the blind spot experiment, I don't want me to come along and say, this is what we do, and this is what you do, and then the students go, oh, half of them can't see it. So I get the students to find out about an experiment. There are many different ones online, and so I'd like each student to come up with a different one. So again, when they report back, hands up who's got a blind spot experiment that works for them, and we'll all do it as they show it. So I'd like one of the students who rarely gets a mark, he'll be chosen first. And I tell everybody, this is why I'm doing it, to get everybody marks. Hopefully everyone gets the same amount of marks by the end of the term. It doesn't always work. If somebody does something wrong, shouting out and wastes a minute of the class, I say, oh, there's 20 people in the class, you've just wasted 1 minute. Of those 20 peoples, that's 20 minutes you owe me. I'll write it down. And so I do. And then the students say, what happens to this 20 minutes? And I say, well, if you do the same thing several times, 3 times, then it becomes a detention. I mean, it's as easy as that. What do you think? You know, detention, weekend detention, what's better for you? I also ask students if they've done something wrong, what sort of punishment should this be? And students will often say, oh, it's detention because it's the only one they know, or the only one they can think of so quickly. And I say, no, I don't want to spend a whole hour with you. What are we going to do? It's like, no. Just write down on this piece of paper. And I get them to write down what they did in, neatly, at what the time that it happened, and say, I'm sorry, and say what class it was. And at the top, put Dear Mum and Dad. Always the last bit. And then they go, ooh, what's this for? I have to do this during my break when I'm saying, I've got to get a coffee, Come get this done so I can go for a coffee and then we don't have a detention thing. So they write it down as quickly as they can. And I often ask them, what were the 3 things you did wrong this lesson? I give them hints so I can get to my coffee. And students will often say things that I didn't know that happened. I say, okay, write that down. That wasn't one of the ones I spotted. And so I get them to write down, just as long as they got 3, it doesn't matter. And what do I do with these letters? I keep them, and if I get 3 of these letters, then I give them to the parents. And I've never yet had to give these things to the parents. But it's there, and it's a consequence, and the students know that it's there, so it changes their behaviour. It's a blind spot experiment. One person comes up, shows how it works for them. Half the people in the class might get it to work for them. Then another person comes up with a different blind spot experiment. And that way, it's them investigating and coming up with their ideas, rather than just me saying and it not working. Other experiments for home. With parental permission. How much faster is boiling water with the lid on or with the lid off? And what are pressure cookers? And why were they so good? Why don't we still have them? Which cools faster, hot water or cold water? And why? And there was a fantastic thing that if you get it right, you can make hot water cool down faster. Yeah, can't remember the name of the effect, but it's in the internet. It's quite a cool one. Very difficult to make it work. What causes the fog at the mouth of a soda bottle when you open it? Why does a bicycle pump get hot when you use it? Stretching an uninflated balloon, what happens to it? Does it get hotter or colder when you stretch it backwards and forwards? When you stretch it, does it get hotter or colder? When you unstretch it, does it get hotter or colder? Can they tell the difference? It's good for experiments for home. And connecting a small and large balloon, not one I like doing in class because of all the balloons going everywhere. It's okay with my GCSE groups and my A-level groups, but not the young ones. Yeah, connect them up with the tube. Small balloon, big balloon, what happens? And yes, I quite realise they're gonna cheat, I suppose, by looking on the internet and finding YouTube, but that's great, I don't care. I need an explanation for it, that's where the big marks are. Just them finding out is all I want. Some of them might get the experiment to work. It's a tricky one to get it work because of the sealing it up. And so that's one of the things that I want to discuss in the next lesson. What's the problem? What's the difficulty of it? There's a reason why I don't do it in class. Another one that I don't do in class, it's a good experiment, is putting a biscuit, a salt biscuit without a salt, on the tongue, and then waiting 5 minutes to see what happens. And I always do it in this voice with my tongue out, because it's interesting. And why don't I do that in class? Do it at home, see if anyone can get it to work. Because I don't do it in school anymore. And I discuss why. Other experiments to do for holidays, skipping stones. Get your dad to show you how to skip stones. How does it work? What's the science behind it? Report back. Another one to do is how to tell whether an egg is boiled or fresh, by several different methods for that. And you know, they might get to try it. Another one to try is have a broomstick and put your fingers underneath it and then move your fingers towards the middle, and you can find that your fingers can get right to the middle and balance the broomstick. Obviously you'll be quite close to the head. How does that work? Why does that work? Do it at home, because it's not one I can do in school. I haven't got that many brooms. Another one for home, or small groups, is 2 balls, one on top of the other. Drop them. It will take many attempts before you get it right. So that when they hit the ground, the ball on the top is still touching the ball on the bottom. What happens? Particularly good if you're using a big bouncy ball and a ping pong ball. The one on the top should be much lighter to get a good effect. And students find out what happened, report back. Good. Other experiments I won't do in class is having a wet finger go around the rim of a wine glass. What happens? And the tin telephone experiment, where you have 2 cans, make a whole piece of string. How do you make it work? Can they get that one to work? On a guitar. If someone's got a guitar at home, tightening and loosing the string, what will that do as a difference? And what's the difference between the long strings and the short strings? Because there are longer ones and shorter ones, and you can put your finger down the string to make it even shorter. Which ones give the higher notes? Well, I don't want to say that, see? I don't want to give any clues away. I want them to come and say it to me. Does sound travel far further, on a cold day or a hot day? So I like things that are absolutely about the world around them. Put in your hand in water. Why is that used as an experiment? Ice water, that is. 50% ice, 50% water, hand fully in. So what's that experiment about? And a door. If it's 1/10 open or fully open, what's the difference in sound compared to closed? There's the wobbly tube swinging around above your head. Sometimes I get students actually bringing a good wobbly tube in to show that experiments to other people. That's a good one. There's the carnival ball experiment, where you have a ball, and if you swing it and try and hit it, the bottle on the way back. So you've just got to make the ball on a rope, swing out and hit the back of the bottle. And it's impossible if you put it right over the middle of the dot underneath the string. Whereas if you put it to one side, you can get it to hit the bottle. So when I'm doing it in a carnival or a school special day, when I'm doing it, I can get it go out and hit the back of the bottle, because I put where the bottle goes. And when the other person's doing it, the bottle is right over the middle, underneath the string. They'll never get it to work. And so that's a nice one to do. There's also the fiddlestick experiment and the magic windmill experiment. Both of those can be found in books and on the internet. And tapping a cup when you have instant coffee. what happens to the sound, the pitch changes. And another one is the sound difference of pouring hot water and cold water. So that's a good experiment to do at home with your mum. Your mum knows whether it's 90 degrees water or whether it's 30 degrees water. And you've got to say whether that one's hot or cold and see how many times you get it right or wrong. Good. And water droplets on a hot frying pan. Another one that has to be done with mum, can't do it at school. Another great one to do is put one hand in a container of very cold water, ice. Another one in warm water. Warm water, yes, but not water that's going to hurt you. So if you're going to boil some water, it's 1 cup of boiled water and 4 cups of tap water, cold tap water, to cool it down a bit. So anyway, and then a middle temperature in between. You take your hand out of the cold water, your hand out of the warm water, put them both in the room temperature water, and they will feel different feelings. And I like not telling my students what they're going to feel, but them telling me what they did feel. And for some people it would be nothing, and for other people it was, oh yeah, I got this happen. Another one is having an egg floating on water, and if you get the water flow to go over the egg will come up. But I don't tell them the result. Another good one to do is a cup half filled with water, a card on the top. It has to be like the Jack of Spades or something. And then turn it upside down and then take your hand away. See if you can make that one work. Another one is a tap running water and bring a spoon close to it to bend the water. Another one is to do exactly the same, but with a non-conductor that's electrical charged. So a plastic ruler will do that, and that's a different sort of reason. Another one is to put a straw in water, a see-through straw, and then blow across the top, and hopefully you'll see the water coming up. Maybe your mum does the blowing and you do the watching. Good. Another experiment to do is the siphon experiment. S-I-P-H-O-N. When I say siphon, then I'll ask students, how do you think you spell that? And I'll give people marks till they eventually get it right and put it in their homework diaries. Do the siphon experiment. Find out about it, get results. Another one to do is a plastic water bottle, make holes using a compass, the pointy piece of a compass, because you're less likely to hurt yourself. Or a thumbtack, but you have to be careful. Fill it full of water, draw a diagram. Which part has the most horizontal spray of the water coming out? And why? Where's the highest pressure? Another one to do is same water bottle full of water and 3 holes close to one another. Do they spread out, the water flows, or do they coalesce? Nice word, coalesce. Another one to do, a water bottle full of water, seeing if you tip it, whether the water comes out quickly when it's full or when it's to the level where air can get in. Which one is the better for tipping? And yeah, you want air to go in usually. There's the putting it something behind, like an arrow, behind a glass container and filling it full of water, and the arrow points the other way. So don't tell the results, just draw the arrow, put it for water, you'll see something hopefully happen. Yep, that one, I can't remember how that one works. Oh, yes! And there's the finger experiment, where you put your fingers like that, down there, like that. And you can lift this finger, you can lift this finger, you can lift this finger, but that finger, your ring finger, is really hard to lift. Don't tell them the results. Just tell them, do that on the table so that the knuckle and this joint are all touching the table. And do the experiment, report back, next lesson. It's always a good way to start a lesson. Yes, if you can get light to go through a straw, you can get diffraction patterns, but it has to be very dark in your room. And if you stir dry sugar, you can also get flashes of light. Just like the flashes of light you get when you take your t-shirt off. It has to be a very dark room in order to do these experiments. Another one is tape from sellotape. Pull the tape, pull another piece of tape, put them close to one another. Do you get repulsion or attraction? Static electricity, nice experiment. Should it be sticky side to sticky side, non-sticky side to non-sticky side, or sticky to non-sticky? And do the experiments, find out which one has the most attraction or repulsion. Another great experiment for the students to do at home is to put a candle in water, light the candle, and the candle will bob there, and as the wax burns away over about half an hour or so, report back what happens. And hopefully you'll get like a circle of wax and the candle will go down and it'll make its own little boat. Cool. And talking about boats, making a boat out of plasticine, why will a blob of plasticine sink, whereas if you make it into a boat shape, it doesn't sink? Cool. Another great experiment is to put a new plastic bottle, so you've just finished drinking it, it's not one you've recycled lots or anything, a plastic bottle full of water into a freezer for 3 hours and then take it out, and then hopefully, if you've done it right, it's still see-through, and you bang it onto the kitchen top and you get nucleation and a cascade of freezing going on, and that's well cool. To add to the mass media like the infinite monkey cage, great one. Give each student a particular episode, a particular series. Tell them to listen to it, report back the best part. Something that takes less than a minute to say.